Here we discuss about the solution of an important problem of dynamics of particle from the chapter plane motion or motion in a plane in Cartesian coordinate. And the problem is a particle moves in a plane being attracted by a force perpendicularly to a fixed straight line in its is equal to mu by distance from the curve whole square. When at a distance c from the line, it is projected with velocity u parallel to the line so that it strikes the line after a time this. Okay. Now here we let the fixed line, this is the fixed line here, fixed line as x-axis, this is fixed line x-axis, and when it projected initially at a distance c from the line, let it be the distance c and this is the perpendicular from this line, and let this is perpendicular line as y-axis. Okay, and we project the particle from here with velocity u parallel to the fixed line. So we can write u, this is equal to x dot, and initially the point of projection is 0, c. Here x dot, this is equal to u, and y dot, this is equal to 0 because there is no velocity perpendicular to the fixed line. Now the curve of the particle, like this curve, okay, let it be strike at the point B. We have to find the time from A to B. This is our result. Okay. Now the force is equal to mu by distance from the curve whole square. Let P be the position of the particle and the coordinate is xy, so the force is always attractive force towards the fixed line, that is x-axis, and force is equal to mu by y square because this is y. Okay. Now the equation of motion or two equation of motion of the particle at any time t at p is given by x double dot, this is equal to 0, this is first equation of motion, and y double dot, this is equal to minus mu by y square, this is second equation of motion, and we take minus mu by y square because the force is attractive or force is towards the fixed point. From the second equation of motion, by multiplying both sides with 2 into y dot, we get this is minus 2 mu y dot by y square. We get d dt of dy dt whole square, and this is minus 2 mu by y square into dy dt. We cancel out dt from both sides and integrating. We get d of dy dt whole square, taking integration, and this is minus 2 mu by y square into dy. This is also integration, and a integrating constant, this is a. This is integrating constant. Now we get y dot square. This is equal to 2 mu by y plus k. Okay. By integrating, we get this result. Now here we apply the initial condition. Initially y dot, this is equal to 0, and y, this is equal to c, and x, this is equal to 0. We put here initial condition and get 0, this is equal to 2 mu by c plus k, that is k, this is equal to minus 2 mu by c. Now putting the value of k, we get y dot square, this is equal to 2 mu by y minus 2 mu by c. right? And taking common 2 mu, we get y into c, this is c minus y, and we get y dot, this is equal to root 2 mu by c into root under c minus y by y, and this is the velocity along y-axis, and this is negative. Why we take negative sign here? Because if we see the motion of the particle, the start from A and go to B, and if we start from A to B, then we look like the y is decreases with time, because this y is greater than this y, this y is greater than this y, also this y is also greater than this y, so y decreases with time, so we must have dy dt is negative. Okay, so we get here a negative sign. Now dy by dt, this is equal to minus root 2 mu by c into root. Initially at the point A, we get t, this is equal to 0, and y, this is equal to c, right? Here t is 0 and y is c. When the particle strikes the fixed line, that is at B, here y must be equal to 0, and let the required time t, this is equal to capital T. Now we integrate this result between two limits. We have integration 2 mu by c into integration dt, and t, this is equal to 0 to capital T, and minus the limit of y, this is equal to y equal to c to 0, because here y equal to c, here y equal to 0, and this is y by c minus y dy, right? Now we change the limit as 0 to c, and we take this is positive, so this is 0 to c, and we make this is positive. Now we get t, this is equal to c by root 2 mu, sorry, this is root under c by 2 mu, and we put here y equal to c cos square theta, and y equal to c cos square theta. This means if we changing the limit of y to theta, we get y equal to 0, y equal to c, and this is when y equal to 0, this is theta equal to pi by 2, and if y equal to c, then this is 0. So the limit is again pi by 2 to 0 and root under, and this is dy, this is equal to 2c cos theta into sin theta, 2c cos theta into sin theta into d theta. This is minus again, because the derivative of cos theta is minus sin theta. So this is also a minus, and the upper part is c cos square theta, and the lower portion is c 1 minus cos square means sin square theta, and dy is minus 2c cos theta sin theta d theta. Okay, so we get here a 2c, and this is 2 into root under cq by 2 mu, and we get this minus is taken already here. Okay, we get integration 0 to pi by 2, because we vanish the minus sign, and this is cos by sin, and here sin into cos, so sin cancel out, this is cos square theta d theta, right? So here we get 2 cos square theta. The formula of 2 cos square theta is root under cq by 2 mu into integration 0 to pi by 2 into 1 plus cos 2 theta d theta, and integrating we get root under CQ by 2 mu into theta plus sin 2 theta by 2. So, and the limit is 0 to pi by 2. So, we get from here by putting limit as root under CQ by 2 mu into pi by 2. So, the time t we get here, t is equal to pi by 2 into root CQ by 2 mu. Okay, so the required time is pi by 2 into root under CQ by 2 mu. This is the time when particle strike the fixed point at B. Okay, and this is the complete solution of the problem. Thank you for watching.